In the section on sampling distributions and estimators, this tends to give people a lot of trouble. You need to make sure that you absolutely understand exactly what you're doing at every minute, because there are several steps to these, and you have to understand exactly what you're doing, when you're doing it, and why you're doing it. In this section on sampling distributions, they're doing a distribution of samples. When the samples are all the same size, we'll call this size n. If you take every possible sample of size n and you look at certain statistics, now these will be statistics because they go with samples. Statistics go with samples, parameters represent the population. What we're always trying to do is use samples to determine parameters for the population, because normally it's nearly impossible to survey every single, say, person in a population. Doing the actual survey of all the people that are going to vote is the vote. So when the vote occurs, that is the survey of the voters that are going to vote. But prior to that, both the people that are interested in the outcome of the vote and, of course, the candidates for the vote are very interested in what is going to happen. And so they'll do surveys to try to see what it looks like people are going to vote for. So anything related to the sample is a statistic. That includes the sample mean, X bar, the sample standard deviation, S, the sample variation, S squared, the proportion, which is P hat, P with the caret over it. Oh, we'll also look at the range and the median. Here's your definition. It turns out that the sampling distribution, the distribution of all the values of a certain statistic of all these samples, so the sampling distribution of all samples of size n will be a normal distribution, even if the distribution of the original population is not normal. A lot of the things we do in statistics will only be applicable to normal distributions. If the characteristic that we're looking for in the original population is normal, then the mean and the standard deviation are applicable. However, it turns out that the sampling distribution of all these samples, they have to be the same size, of size n, will be normal even if the population distribution is not. So the sampling distribution is still going to have, can't draw it, but the sampling distribution is still going to have a normal distribution. The mean of the sample means will target the mean of the population. You have to understand what this means. if you take every one of the samples of a certain size and you get the mean of that sample, and then you take every one of those samples and you get the mean of all the sample means. So you take the mean of this sample and this sample and this sample and this sample and this sample, and then you calculate the mean of all those means. So you add up all the means and divide by the number of means. That will target or aim toward calculating the mean of the actual population. And the distribution of the sample means will be normal. This is also true for the mean of the sample proportions. We'll target the proportion for the population, like the number of people that are going to vote for candidate A. The mean of the sample variances will target the variance of the population. So the sample means, the sample proportions, and the sample variances, when you take every one of those and then you get the mean of those, you will, for practical purposes, have the value, the mean, proportion, or the variance of the population as a whole. Now, the mean of the standard deviation is going to be a little off. However, unless it's a really small population or it's really, really far off, as off of being normal, then you can also do the mean of the standard deviations and have something close enough to the standard deviation of the population to be usable. Now, what does not target the mean of the population at all is the mean of the standard of the sample ranges. And the mean of the sample medians. Do not. If you get the mean average of all of the ranges of all of the samples, it is not going to give you any idea what the range of the population is. And the same holds true for the median. So this applies to the means, the proportions, and the variances. It applies somewhat, it'll be close to the standard deviation. It does not apply to the ranges and the medians. What they're going to ask you to do in the problems in this section is they're going to give you a very, very small population, perhaps 3 things. So perhaps your population will consist of the numbers 3, 7, and 12. And then they'll give you a sample size, typically 2. Now I know this seems kind of silly, but if you take every possible sample of size 2 from this population of size 3, you're going to actually have 9 samples just from that. For each of those 9 samples, you're going to have to calculate whatever the statistic in question is. The mean, the proportion, the variance, standard deviation, the range, or the median. You'll have to calculate that for every single one of the 9 samples. If the population has 4 in it, there will be 16 samples. Then you'll have to get the average of the statistic in question from each of the 9 or 16 samples. So if they're talking about the mean, you'll have to take the 9 samples, figure out what the mean is, take every one of those means and get the mean of the means. So you take all 9 means, you add them together, you divide by 9. That is the mean of the means. And then they want you to compare that statistic to the parameter, the same parameter, corresponding parameter to the population. So again, if we're talking about the mean, you're going to have to take the 3 numbers, add them together, and divide by 3 to get the mean for the population, and compare them to see if they're the same. The mean for both will turn out to be the same. So the mean of the means of the samples is going to be the same as the mean of the population. The proportion, the mean of the proportions from the samples will turn out to be the same as the proportion in the population. Same for the variance. The standard deviation with just a population of 3 could actually be way off. The range and the median, they'll have you do just to show you that it doesn't work the same way. So you have to be very careful to keep exact track of what you're doing at the moment. And I'm going to show you how you can do most of this in StatCrunch. Here's a problem. 3 randomly selected households are surveyed. Now, this is our population. So the numbers of the people that live in these homes, one has 10 people living there. One has 10, one has 4, one house only has 1 person. They want us to find samples of size n equals 2. These are going to be selected with replacement. So that means that the first thing in our sample could have any of these numbers, a 1 or a 4 or a 10. And then the second element in our sample likewise could be a 1 or a 4 or a 10. So our samples are going to consist of a 1 and a 1, or a 1 and a 4, or a 1 and a 10. Or a 4 and a 1, or a 4 and a 4, or a 4 and a 10. Or a 10 and a 1, or a 10 and a 4, or a 10 and a 10. Now we have to do this with replacement because in order for this stuff to work, your random sample has to be independent. You have to have the same probability when you select the second element as you did the first. So especially with just a sample of 3, there's no way to choose a sample size of less than 5%. Remember? Okay, so we have our 9 samples. Now, they want us to find the variance of each of these samples. So recall, finding the variance means finding the mean, subtracting each element minus the mean, square that, get the sum of all those. Okay, there's an easier way to do that and to do it in StatCrunch. Let me clear this. I'm going to load this into StatCrunch. I'm going to separate these out so that we can see both at the same time. Okay, the first column is just numbering the samples. We have sample number 1, 2, 3, 4. We don't actually need this column. We're not going to do anything with it. The second column has our first element, our x1, and the second column has our second element, x2. So our samples are actually listed horizontally here in the rows. Sample with 1, 1, 1, 4, 1, 10, 4, 1, etc. The way to get our variance with the samples consisting of numbers that are beside each other is to go to Stat, Summary Stats, and instead of columns like we normally do, we're going to select rows. Now this is just to get our variance or our mean or whatever from our samples. So Stat, Summary Stats. The columns we're interested in are x1 and x2, so I'm holding down the bar on my laptop, or you can do it on your mouse, and just sliding through x1 and x2. I'm interested in the variance. That's all I really care about right now. Keep moving this around out of the way. So I'm going to hit compute. Now this gives me my variance for each sample. So I've got the variance for row 1, row 2, all the way down. Over here in the problem, if you look at these drop-down lists, they want us to find the variance of each of the 9 samples, then summarize the sampling distribution in the format of a table. So there are actually only 4 different values over here. I can make this a little bit easier by clicking on variance, and it'll sort it based on the variance. So now I can easily see that 3 of the samples had a variance of 0. So my variance is 0, and the probability is 3 of the 9. Now in some of the problems, you can put 3 over 9, but then in some of the problems later, if you don't reduce the fraction, it will count it wrong. So I would suggest going ahead and typing that in as 1/3. It says type an integer or a fraction. Well, the only way you can have an integer for a probability is when it's either 0 or 1. So these are going to be fractions. Now my next one is 4.5, right there. There are 2 of those, so 2 out of 9. The next one is 18. Here we go. And they want you to put these in, it says down here, in ascending order, so you have to start at the bottom and work up. So 2 out of 9. And my last value for the variance is 40.5. And again, 2 out of the 9. Okay, so I have my list of the variances from the samples and their probability. Now I'm going to need to get the mean of these variances. And the easiest way to do that involves copying the variance into StatCrunch. And for some reason, when I tried just typing those numbers in the other day, it did not work. It's like what I typed in wasn't a real number. So I'm going to do a copy on these. I started at the very top, and make sure you pick up on this row 1. And then I held it down and pulled it down all the way through those. I'm going to hit a Control-C to copy. I'm going to come over here. I'm going to do a Control-V to paste it. I'm going to close that to get it out of my way. So I've copied all of these in here. I'm going to change the name of this to say Variances. And I'm going to change this to row or rows or whatever, just so it makes it easier when I see a list of stuff to remember which is which. Okay, so X1 actually has each member of my population listed 3 times. X2 has the same, just in a different order. So I'm going to end up needing the mean of my variances, and I'm going to need the variance of the population. You follow that? I've got the variance of each sample, and I'm going to take the mean of the variances of all the samples and compare it to the true variance of the population, both of which I can do in StatCrunch. What order are they asking for over here? Let me hit continue. Compare the population variance to the mean of the sample variances. Okay. So I'm going to need the population variance. That is sigma squared. I'm going to need the mean of the sample variances. So the mean of the sample variances, and that would be the mean of the S squareds, that's what these are. So I can do, to get the population variance and to get the mean of the sample variances, I can get the population variance by going to Summary Stats, just like before, only this time I'm going to go back to the usual of clicking on the column. Now X1 and X2 both actually have the same. I don't need the variance of the variances. Just because you get the mean of the means doesn't mean you're going to get the variance of the variances. I'm going to get the mean of everything for the samples. I'm going to get the actual variance of the population, and row 1 and row 2 or column X1 and X2 are going to give me the same thing. If I hit the variance and compute, the variance is of the population is 15.75. Now I need the mean of the variances for the samples. So I need the mean of the variance column here. So I'm going to hit Stat, Summary Stats. It's in a column. I want the mean. Oh, I got to tell it which column. I want the variances. I want the mean of the variances. Remember, I typed in variance myself. Oh, I just realized why that came out different. Okay, the problem here is that StatCrunch does not calculate a population variance, it calculates a sample variance. So StatCrunch doesn't give us an option to do a choice of a population variance or a sample variance. So StatCrunch got the sum of the x minus mu's squared and divided it by 8 instead of 9. To fix this, because they divided by 8 instead of 9, we want to multiply it by 8 to undivide it by the 8 and then divide it by 9 instead. So I'm going to take the 15.75. I'm going to multiply it by 8 and then divide it by 9. Understand? StatCrunch only gets sample variances, and this is a population variance. So they divided by 8 instead of dividing by 9. So I'm going to take the 15.75 and multiply it by 8 to undivide it by 8 and then divide it by 9 instead. And this turns out to be 14. So the sample variances will be correct. They're samples. The mean of the sample variance will be correct. The population variance or the population standard deviation is going to be off because StatCrunch will use the formula for the sample variance and standard deviation. So when you do a variance, you need to multiply it by the n minus 1. So if you've got 9 samples, n minus 1 is going to be 8. And then go back and divide it by the actual number of samples, n, instead of n minus 1, and that should take care of it. So this shows that the population variance is actually equal to the mean of the sample variances. Let's try another one. Oh, continue. I'll let you finish that one. The sample variances do target the population variances. Therefore, sample variances do make good estimators of population variances. They're a good way to estimate what the true value is. In this problem, we have a population consisting, again, of the set, this time 2, 4, and 9. They want us to get the samples of size n equals 2, and they've gotten all of those for us. This time they want us to find the population standard deviation. So we're going to be working with standard deviations this time. And again, this is the one that StatCrunch will not calculate, is a population standard deviation. So the formula for the population standard deviation, remember the variance is the x's minus the mu squared divided by n, the population number. And then the standard deviation is the square root of all that. So before we multiplied by the 8 to make up for dividing by 8 instead of 9. We multiplied by 8 and then divided by 9. This time we would have to multiply by the square root of 8 and then divide by the square root of 9. You know, the variation is the square of the standard deviation. That's going to be the sum of the x minus mu's divided by n, but what they're actually going to give us from StatCrunch is the sum of the x minus mu's squared divided by n minus 1. So we're going to multiply by n minus 1, n is 8, or n minus 1 is 8, and then divide by n to make up for it. So why don't we do this? Let's get the sample variance, multiply that by 8 and divide by 9, and then take the square root to get the population standard deviation. Understand? We want this. StatCrunch is going to give us this. So we are going to multiply by 8 that they divided by, and then divide by the 9 to correct it from the sample standard deviation to the population standard deviation. That's actually going to be the variance. Let's get the variance. Multiply by 8, divide by 9, and then take the square root. Let's see how that works. I'm going to load this into StatCrunch. I'll pull this over to the side. So I'm going to get stat, summary stats. It's in a column. Either of those columns where the data is. The standard deviation is going to be the same whether we take the 3 of them and just use those, or we have 3 of each. As long as we've got exactly the same number of each, the total is going to be 3 times as big, but then we're going to divide by 3 times as large a number. So let's get the variance. The variance is 9.75. This is the variance. I'm going to take the 9.75. I'm going to multiply by the 8 and then divide by the 9 to correct the denominator. 9.75 times 8 divided by 9 is basically 8 2/3, 8.66667. And then because that's the variance, I'm going to do the square root. I've already corrected the denominator. So the square root is 2.3 decimal places, 2.944. Okay, so clear the screen. We've got the correct population standard deviation. That's going to be the only correction we need to make. So now we want to find the standard deviation of each of the samples and then summarize the sampling distribution in this format in this table. Use ascending order of the sample standard deviations. So I need to get the standard deviation, and these will be samples, standard deviation of each of these groups, here, here, etc. So I'm going to do stat, summary stats. I'm going to do this in rows. This is where I have to go across to get the standard deviation for each row. My rows are in the X1 and X2 columns. I don't want to include the row number in that. I want the standard deviation. This is for a sample, so this will be correct. It's going to give me all the possible standard deviations for each of the 9 samples. Let's go ahead and sort that. So 0 occurs 3 times. So the probability for that is 3 out of 9, or 1/3. And then 1.4142, okay, occurs twice, 2 out of 9. 3.536, okay, occurs twice out of 9. 14950, 4.950 occurs twice. Then we have to get the mean of the standard deviations. So if I come over here and copy this back into StatCrunch, so highlight, Control C, and then Control V to paste it, and then I can close that. To get the mean of this column, I'm going to do Stat, Summary Stats, column. That is variable 5. I didn't change the heading this time. I want the mean, compute. So the mean of the sample standard deviations is going to be 3 decimal places. 1998 would become 2.200. So 2.2 is actually 3 decimal places. Now, the population standard deviation was 2.944. The mean of the sampling distribution of the sample standard deviations is 2.2. Recall that only when you have a really large population are you going to be able to use the standard deviation as your estimator, because the standard deviation in itself will not target the standard deviation for the population. So in this case, it did not work. The sample standard deviations do target, no, do not target the population standard deviation. Therefore, sample standard deviations are biased estimators. This is correct. It's not good to be biased.